In this video, I will show you one option that you can do when facilitating an Explore Synthesis conversation for Unit 7, Day 29, Lesson 15a, Quadratic Equations with Irrational Solutions. The focus question of this lesson is how can we find exact solutions to quadratic equations that are irrational? So I went ahead and put this lesson on Desmos as a way to facilitate it. And students in this lesson, I'll just show you first, and this is on Desmos as well. Students are first exposed to this idea of writing the solution to a quadratic equation when it's the same number and its opposite as a plus minus 5, or in this one, positive negative, the square root of 24, positive negative 4.9 as an estimation. Okay, so they're exposed to this in the launch. You want to facilitate a conversation and really just let students know that we can write x equals 5 and x equals negative 5 are the solutions, but an even shorter way to write this is x equals positive or negative 5. And so in the Explore, students are asked to solve a number of questions where their solution may be irrational. And they can practice writing their solution in this way as positive, negative. Now, just to point out on Desmos, it doesn't have a way for students to easily write positive, negative. So if you look here, when they're solving an equation like this, they can either, they can write it in both ways, x equals the square root of 18 and negative square root of 18, or you can even just instruct them that they can write it like this, if they would like, plus or minus square root of 18. Because Desmos doesn't show us doing it as the one symbol, unfortunately. I can't seem to figure out how to do that. Okay, so for this one, students, for the last question, students are asked to solve this equation. The quantity of x plus 1 raised to the second power equals 18. And so I snapshotted 3 different samples of work that we can look at that will help us guide the conversation. Now, as you probably already know, when they solve this, they're going to get an answer that's irrational. And that's part of the conversation we can have through this facilitation. So I snapshotted 3 students' work. The first piece of student work I chose to snapshot is this piece of work. And the question I asked is, what is the misconception? So during class, you can facilitate this conversation if you see any students having this misconception by just asking the class, what is the misconception happening here? Students should notice that instead of square rooting 18, they divided 18 by 2. And that's a common thing that students will do. So somebody might point that out, and then we can ask, what does it mean to square root a number? It means to find 2 of the exact same numbers that multiply to that number. 9 times 9 does not equal 18, it equals 81. So what is the square root of 18? Well, it's not going to be a whole even number. And that's even where we can talk about, let's look at it. What happens when we do the square root of 18 on a calculator? Is there a calculator on here? No, I wish there was one right on the screen. But if we do the square root of 18 on a calculator, we get this long, really long number. And this number will actually go on forever because it's not an exact number. This is called an irrational number. There's no pattern 2, 4, 2, 6, 4, 0, 6, 8, 7, 1, 2. You don't start to see any type of pattern. It goes on forever in this kind of crazy way. So that's how I like to tell students is it's irrational. It doesn't make sense. We don't have any idea what number comes next unless the calculator shows us. And so we can round this if we want to, or we could just keep it as x plus 1 equals the square root of 18 and x plus 1 equals the square root of negative 18. And that's what we're going to be working with in this unit is we're going to talk about or in this lesson and some upcoming lessons, we're going to talk about and learn about when our solutions to quadratic equations aren't these nice rational numbers, but instead are irrational numbers. And so you may be wondering, right, and this is something to tell the students, you may be wondering, well, what is a rational number and what is an irrational number? What is the exact definition? You can prompt students if they know, or if they don't know, you could just kind of give it to them. A rational number is any number that can be written as a fraction and its opposite. So maybe you take some examples of rational numbers. 12, negative 7, 1/9, negative 1/8, 90.38, 0.005. How would we write this as a fraction? You might even ask students to prove that that's a rational number. Ratio, where do you see anything that sounds like fraction in the definition? Ratio, rational. Fractions are, is another way to think of a ratio. You can write ratios as fractions. And then makes sense. There's a pattern. If I, and this is getting far into it because we will discuss rational numbers a little bit more, but just to show you, because this is something I didn't always realize. If I do 1/9, although it's a repeating, it is a repeating decimal and it makes sense, right? It's just 1, 1, 1, 1, 1. We know 1 comes next. 1/7 is repeating decimal, but look, you start to see the pattern. 142,857. 142,855. What do you think is going to come next? 7. So they make sense. There's something rational about their pattern. Okay. Oops. And so this is where you can kind of start talking about that difference between rational and irrational numbers. And an irrational number, for at least this time, can just be noted as a number that's not rational. What are some examples? The square root of 2, pi, the square root of 10. Really, any non-perfect square is an irrational number. And again, this is something that we will get into more, but it's just good to talk about it a little bit here. So then on the next slide, I have students, I chose 2 pieces of work, and I'm asking students to compare and contrast the strategies. Well, what did they do similarly? What did they do differently? Similarly, they both square rooted as a first step. They both found the square root of 18 and the square root of negative 18 as their solutions. They both subtracted 1 on both sides to get the square root of 18 minus 1 and the negative square root of 18 minus 1. But then this person actually found 2 answers, and this person rewrote their solution in this way. So let's talk about it. What do you know about these solutions? Well, they're not exact. Why? Because they're irrational numbers. When I put that in the calculator, you're not going to get exactly this. They rounded to the nearest hundredths place. Interesting. So why might not this be the way we want to show our solutions? They're not exact. Exactly. In algebra, we push ourselves to be as exact as possible. So sometimes it will be asked to round our solutions and give an approximate solution. But other times we're asked to give an exact solution, and that's where this comes in. Can anybody explain how they got from here to here? How did I get from here to here? Oh, well, they just said they're both subtracting 1, so they just said positive or negative 18, square root of 18 subtracted by 1. Fantastic, exactly. So this is the simplest way to write this, and that's something we are going to really want to continue to practice, is how can we really simplify the way we write our solutions? Can anybody write this another way? And you can get into it, right? Negative 1 plus or minus the square root of 18. Negative 1 plus the square root of 18. Negative 1 minus the square root of 18. Right? So you can look at these different ways and have that conversation and say that we're going to really try today and over the next couple of days to push ourselves to write these exact solutions in the simplest way. So you can even tell students, go back to your other answers and see if you can rewrite them using and rewrite them as an exact solution in the simplest way. Okay. And so in here, I included an extra slide that wasn't in the lesson where it asked students to describe why all of these are different ways of expressing the same solution. So giving them a chance to really synthesize that conversation, and then you can go ahead and talk about that as well. And then the summary question is, how can we find exact solutions to quadratic equations that are irrational? And students can have a chance to really reflect here, and this can be kind of a formative assessment for you. Okay, so in summary, this lesson really focuses on having students start to think about how they can represent irrational solutions of quadratic equations. So when you're having your summary conversation, that's something you're going to want to focus on and feature and think about those different representations.